Huh? Number 10. All right. Sweet. Okay. So, my plan for today is I want to go through 10 and 11. Being that you're here, you got the points for doing them. Being if you weren't here, then you better do them and go through it. All right, let's. So we are continuing our adventure with quadratics. Quadratics are raised to the second power. Quadratics make parabolas. Parabolas open up or down, things like that. So sometimes when you start working with projectile problems, the item can be represented on a graphing calculator pretty easily. I'm going to work through these not using a graphing calculator. Though it is valuable, I just don't know. Not all of you have a graphing calculator, so I don't want to go to one way saying, here, I'm going to do it this way, and the rest of you are going, well, shoot, that stinks, I don't have it. So I'm just going to walk through them. But if you do have a calculator, even if it's on your cell phone, let's have that out and ready. Is that okay?
Wait, so this is like a one-time thing?
Yeah, like, so if your calculator works on your cell phone, have that out and ready.
You know, I'm just going to use my own.
Okay, it's up to you.
I still think we're breaking the rules.
It's okay if you break the rules a little bit. All right, so let's see. It says calculator problem, and we can do this by hand. I mean, we have the capabilities of doing it. It says use the function h at t equals negative 16t squared plus vt plus s. Now, the negative 16, this is where the negative 16 comes from. Remember we said the acceleration of gravity is negative 32 feet per second? Remember that? Yeah. And then remember the equation I used yesterday? That was distance equals 1/2 at squared. Remember that? Well, that 1/2 times negative 32 is what? 1/2 times negative 32 is what? It's negative 16. So that negative 16 comes so we don't have to use the fraction. They're already assuming the fraction. So the d equals 1/2 at squared that we started working with yesterday is the same equation that we're going to use. It's just that they don't use the 1/2 any longer. They realize that if I go 1/2 times negative 32, I get negative 16. Does that make sense? Okay, it says a rocket is launched from an 80-foot tower with an initial upward velocity of 212 feet per second. Okay, so let's think about this. You have this tower, and you're launching your rocket upward, and it's going to do something like that. Does that picture make sense? And this picture, this height that from here to here to the ground is 80 feet, they're telling us. So you had a taller object you launch off of. It's like you're throwing something off a building, things like that. So, but you're launching a rocket upward. It has an initial velocity of 212 feet per second. Okay, so it's for every second it goes, it's going 212 feet until it's gets to its maximum height. So this v is velocity. And again, these are what the worksheets that you have, but that's your velocity. Your s here is your height that it started from. If you start on the ground and it's going to come back to the ground, your initial height is ground level, which is 0. If you start below the ground, like if you're in a hole and you shoot a rocket up or you throw a rock upward or whatever, then you're starting at a negative position because it's below what the ground level is. Okay? So, find the maximum height reached by this rocket and the time that occurs. Okay, so we are going to let me just take the equation h at t, and that's the same thing as saying y. Okay, we're just using a function notation. And then we're going to go negative 16t squared, and we're going to plug in what we know. Our initial velocity is going upward at 200. Our initial upward velocity. So if you see the word upward, it means it has to be positive. Okay. If you were on top of a building and you're throwing downward, you would have a negative velocity because you're heading towards the ground. So your upward velocity is going to be positive, and then you have 212, and then there's a t there that's attached. So t squared t. Here's your linear component, here's your quadratic component. And then s is your wherever you started from. So we happen to be 80 feet above the ground. So we're going to call this plus 80. So this is like saying y equals negative 16x squared plus 212x plus 80. We're using time, or t, to represent time. H at t is the height with respect to time. Does that make sense? Okay, so find the maximum height for the rocket that it reached. Well, the maximum height up here is your vertex. And when we're set up in this form, we know that we can use negative b over 2a and then pi for plug in, right? Not 3.14. Okay? Now this is where I'm going to need your help. You have the calculator. Okay, so let's do negative b over 2a. So I have negative 212 over 2 times negative 16. Did I do that right? Did you see where I got my numbers from? Our a value is negative 16, our b value is 212, and our c value is 80. So I have negative b, so negative b is negative 212 over 2a. A happens to be negative 16. So negative over negative, so here's our plug-in. Negative over negative is positive, okay? And then 2 times 16 is 32. Could somebody help me out? You have your calculators out. It's 212 divided by 32. 6.625. I like it. All right. Now we're going to take that and we're going to plug it back in, and this is where it gets a little tougher. So I'm going to bring the work down here. So I have negative 16 times 6.625 squared. I'm just plugging it back into here. Plus 212 times plus 80. Okay? So some of your calculators can accept this much work all at once. Sometimes it won't. Okay? Sometimes you have the bigger TI-83s or the 84s or the 89s or any of those. You should be able to go negative 16 parentheses 6.625 close parentheses squared plus 212 parentheses 6.625 close parentheses plus 80, and it'll give you an answer. Sometimes your calculator won't handle that much, so you have to go a little bit at a time. So the first thing you should do is take care of 6.625 squared. And then you multiply times negative 16, and that gives you a negative answer. And then you go 212 times 6.625, and that gives you a positive answer. So you take your negative answer, add it to your positive answer, and then add 80 to it. So does someone have a big enough calculator you're able to go all the way across with, how much? 782. 782.25 you said? Okay. Does someone else verify that? Does that work? Yeah? Was that a yes? Yeah. Yeah, you. You got a calc in here, huh? Did you get it? So our vertex to this parabola is 6.625 comma 782.25. So let's decipher what this means. What does t represent? What does t represent in our problem? Time. In what units? Seconds. Time in seconds. Does that make sense? So our t value is the same as what value normally? X. Okay? So this is an x value, which is a t value in this case, and t represents time in seconds. So at 6.625 seconds after we've launched, does this make sense how I'm saying it? So it launches. We count 1001, 1002, 1003, 1004, 1005, 1006, it's at its maximum height. Now it's on its way back down. H means height. So the height with respect to time. So how would you say that our vertex relates to the maximum height? How would you say it like as a sentence? At 6.625 seconds, we are at feet. Good. So at 6.625 seconds after our launch, our rocket had attained a maximum height of 782.25 feet. Does that make sense how I just stated that? So, it got up there pretty high. You're like, oh, cool. Is it up to a mile high? No, a mile is 5,280 feet. We're only at 782 feet. A little bit more than that. Okay? So, find the maximum height reached at the rocket and the time in which it occurred. Did we answer letter A? Find the maximum height reached by the rocket and the time in which it occurs. Yeah. 6.625 seconds after we launched, our rocket made it to 782.25 feet. And that's 782.25 feet above the ground. So from here, so eyes up here. From our ground to here is that height. It's not that much higher than that. If it was, we'd have to add 80. Okay, it's only 702.25 feet taller than our building that we launched it from. So that's how high it is above the ground. So if your buddy's standing down here on the ground like, oh, cool, look, and he's looking up there, that happens to be 782.25 feet above him. If your buddy who's standing on top of the launch pad is standing up here, looking up here, he only sees it as 702.25 feet above him because he's 80 feet above the ground level. Did that make sense how I stated that? Okay. Now it says find the height at 3 seconds. Find the height at 3 seconds. Now let me ask you this. If this is our maximum height and it took me that long to get there, what can you tell me about 3 seconds? It's half 782. Could be. Okay, that'd be a good prediction. So 3 seconds is half of that, or a little less than that. So it might be half of that. It might be that relationship, but I'm not quite sure. So how would I figure out, using my equation, what would happen after 3 seconds? Yeah, you're going to plug that 3 seconds now. This 3 seconds here, I'm going to plug here and here. So that gives me negative 16, 3 squared, plus 212 times 3 plus 80. Does someone have a big enough calculator to do that whole string in there? If not, it's negative 16 times 9 because 3 squared is 9. 212 times 3, bless you, is 636, and then add 82. Bless you. You get an answer there? $572? Yeah, letter B, yes. 572? I have someone said 572. What do you think? You have 860? Okay. So we have 2 answers so far. One of 782 and one of 860. Your whole calculator should be able to put that whole string in. So negative 16 parentheses 6.625 squared plus 212 times 6.265 plus 80. $572. That was what you had, Garvey? Okay. So I think 572 feet makes sense. Andrew, what did you have for an answer? 860. Okay. So I think that's good for the running, but you probably just plugged it in wrong. But I want you to, as critically thinking, to kind of think about this. Okay? And you had an error in your work, and that's okay. But logically thinking, think about it this way. What is our maximum height supposed to be because of part A? 782. So you getting an answer bigger than that should be a red flag of, ooh, maybe I plugged something in incorrectly. Okay? And that's where a good part of logic and thought process takes place on any problem solving. You know, it's kind of like that whole spiel of you might see a question given to you some point on some test that is, you know, ACT or SAT or whatever. That might be a banking statement question. You invest $1,000 into a bank account after 2 weeks, and you know, all of a sudden you're at, you know, $17 million. No, it doesn't work that way. You're way off far. So you realize that sometimes there's a thought process. So, Andrew, I'm going to tell you this. You used good critical thinking and thought analysis on your problem, but now you can take it one step farther going, there must be a small error I made because logically this should not happen. Because the parabola did this, and it's open downward, and this is our maximum height. Now we're getting a height here that's above that. So we didn't have something magical happen. So that's what I want you to, you know, start realizing, and it's okay. It's a thought process, and it's adequate. And sometimes there might be a test saying, you know, that'd be a great test question for me to give you guys. You know, I could say, you know, if I had something on your review, I could say something like, you know, Casey and Andrew were throwing rocks at each other. Andrew decided to throw a rock up at this height, and you realized the maximum height was 45 feet. And then after 2 seconds, how high is it? And Casey came up with an answer of 7,000 feet. Something happened. You know, superpowers took place, but logically it shouldn't happen that way. So, yeah. Tuesday. Yeah, we're going to start the review today. It's a worksheet, and then we will complete it all on Monday, make sure everyone's good, and then Tuesday we'll do the test, okay? Find the time at which the rocket reaches the ground. Find the time that the rocket reaches the ground. So, it reaches the ground right here. So, here's a big error. The big error that takes place sometimes. Okay? Someone with a calculator, could you go 6.625 times 2? 6.625 times 2. 13.25. Okay, here's a big error. Ears open, eyes up here. 13 what? Okay, a real easy error for a student to do on this type of problem is, at 13.25 seconds, the rocket hits the ground. Okay? That would be entirely correct if the rocket had been launched from ground level and came back to the ground level. Was our rocket launched from ground level? No. So you can't just double the x component on your parabola to tell me, or in your vertex to tell me that that's when it hit the ground. Okay? So what you have to do is now you have to take your problem, this problem here, I have negative 16 t squared plus 212 t plus 80 is equal to 0. Okay? I want to pull up, so I'm the room on here. Coming up. That's our notebook. We're being a dumb notebook. All right, so I just wanted to pull this up so we can do this. So we're going to use this same. So t represents what letter? Time. But if we had this as a quadratic with y and x, this represents what letter? X. So this could be written to be this. Yes? Should we try to factor this? Okay, so if we're going to factor it, we're going to multiply 80 times negative 16 and find all the factors of that. Should we factor this?
Yes.
You're a crazy guy. I don't think we should factor it. I think we need to go to our buddy. You with me? Okay, negative b, negative b. What's negative b? What's negative b? 212, thank you. Plus or minus square root 212 squared minus 4. What's a? Negative 16. Careful with your signs. What's c? 80. Divided by 2 times negative 16. Yes? Does everyone feel okay with that? These are going to be big numbers, yes? This is not the one where you sit there and said, oh, I did it in my head. Right? So let's slowly go through it, see if we can figure this out. Extend the page. Somebody help me out. What is 212 squared, please? Should be probably a 5 or 6 digit number. 44,944. Do we have a second on that?
Yeah.
Good, thank you. All right, now logically, negative times positive. Negative times positive. Positive, you okay there?
Yeah.
Now let's not worry about the signs anymore. Are our signs going to be correct now with this?
Yeah.
Okay, 4 times 16. 64? Yeah?
Yeah.
64 times 80. 5,000 what? 120. Is my math right? All over negative 32. Still with me? So we're trying to figure out when this rocket hit the ground, right? How many answers should we have on this problem?
Oh, 2.
2. But let's see what happens when we work it out. So I'm going to extend down further. All right, help me out. Someone add that together for me. How much? 50,000, like this. Is that right? Okay, and that's still over negative 32. 32, squeeze in there. Someone take the square root of that for me, please. How much? 223.7. Okay, over negative 32. Okay. So this is still going to give us 2 different answers. Do you agree?
Yeah.
Okay, let's see what happens. Go negative 212 plus 223.7, excuse me. So negative 212 plus 223.7. Whatever that answer comes out to, divide by negative 32. Point what? 365. That's good enough. Okay, now I'm going to go negative 212 minus 223. Negative 212 minus 223.7. Whatever that answer gives you, divide by negative 32. Negative 212 minus 223.7. Whatever that answer is, divided by negative 32, please. 13.59. Positive, right? Okay. Here's critical thinking. Does it make sense to have a negative amount of time in this scenario? No. Okay? So the negative, it's kind of like when you're finding the area of something or your length and width of something and one of the answers comes out negative, you're not going to have a negative length or width, right? So this negative answer here won't work. So at 13.59 seconds after we have launched, so from here to here, at 13.59 seconds, your buddy on the ground better get out of the way because it's coming. Does that make sense? Is that answer pretty close to us just doubling the x component of our vertex? What was this answer? Go 6.625 times 2. Help me out. 6.625 times 2. 13 point what? So 13.25 is pretty close to this, but it's not the right answer. So don't double. So a rule of thumb is you could try and double it, say, hey, am I kind of in the ballpark? But if you double this, you do not get this. It's the wrong answer because you launched it from a top of a tower and it's now getting to a further down place. So at 13.59 seconds, our rocket is now on the ground. Okay? You know what this application is used for? Well, you're out at sea, you're on this big old battleship. And you got troops on the ground and wherever we're fighting bad guys. They're going to call in. They're going to say, hey, listen, we need cover fire. This is our location. The location we want you to hit is this other spot. Okay? Now, the nice thing is we are so good with GPS these days that I could say, I could be a spotter for the military. So I'm out on the ground. Or I could be flying in a helicopter or a jet. And I could point a laser, and that's going to tell me the exact GPS coordinates. And then I could send those GPS coordinates, those exact GPS coordinates, back to the ship out at sea, safe out at sea. They're eating, great dinner. And then all of a sudden, hey, we got to shoot a bomb. Oh, okay. And they plug it in correctly. What's the difference between this and the one that was a little bit off? The one that's a little bit off might destroy your troops. It didn't hit your target. So the accuracy part is real. This is a real type of problem. Now, the military, fortunately, someone has programmed into the computers how to calibrate things. So you type in the coordinates, and it figures out where the ship is at in the location with GPS. It takes into account how fast or slow the ship is going, and it takes in a few other factors. But this, for the small part of the math, is actual math they're doing. Now, some of you are like, oh, I'm anti-war. I get it. I'm not trying to say I'm for or against war. I'm just saying this is how some of this math might be used. Okay? So that's just one idea of how to use it. This is what the Air Force, the Navy, the Army, the Marines, they use consistently. What's our goal during time of battle? To win. And to have the least amount of our casualties possible. Okay? Hey!
Hello.
Oh, yeah. Oh, yeah! All right. Sophia, bring your things with you, please.
Oh, snap.
They caught you playing with matches, finally.
Oh my god.
Finally.
Oh, don't forget your Coke.
I told you about the hand sanitizer and you didn't do anything.
Start crying.
Have fun, man.
Good luck.
Watch out, she might run it.
Blame Gage if you need to.
Gage, you're horrible.
I'm sorry.
No, you're not.
Gage, you got an earbud in.
Not anymore.
Ah, that's right. I know you forgot it was there. Huh. All right. Let me. Uh-oh. How do I clear my writing? No, that didn't work. I forgot. How do I clear my writing? Help.
No.
Where?
I don't think that's it. It was in the right corner. You always used to do it in the right corner.
Top right.
Top right, top right.
Smart.
Oh, there we go. Good, love you. Thank you. Clearing. Yes! Thanks, man! Oh, sorry, it's been a while since I did this. Thank you. You guys rock. All right. The next problem we're working on. Shh. Next problem. Shh. Okay, so we have this picture of a rectangle and a circle that are there, and I know the graphics are through the roof.
Dude, this is like pre-Stone Age.
Yeah, I know. All right, the height of a rectangle above is the same as the radius of the circle. So the height of the rectangle, so how tall this rectangle is here is the same as the radius of the circle. That's what they're trying to say.
So two of those rectangles would fill up the circle.
Would be the diameter. I like it. Okay, good logical thinking. The perimeter of the rectangle is 16 centimeters. So the distance all the way around a rectangle. So if we're talking about the perimeter of the rectangle, I know that perimeter. Whoa, hey, smarty. Going back to the pen. We're the red one this time. I know, we're going to cut you. All right, so the perimeter, I know the perimeter is 2 times the length plus 2 times the width. And they tell us that the perimeter of the rectangle happens to be 16 centimeters. Yay? Okay. All right. Which means the length of the rectangle is 8 minus x. So the length is equal to 8 minus x. Therefore, the area of the circle is x, which equals pi r squared. All right, so the perimeter of the rectangle is 16 centimeters, which means the length of it is 8 minus x. Therefore, the area of the circle is pi x squared. Okay. All right, I don't know if I can put that up here. The area of the rectangle, oh, they give us the area of the rectangle. The area of the rectangle is x times x minus, or 8 minus x. So they gave us that from here. Okay? Okay, so they told us that the area of the circle is equal to pi x squared, which is r squared. You're correct, but they're saying it's x because they're calling the length, so the long side, we've been indoctrinated to realize that's the long side, and the width, with our labeling, takes place as that. So that means that this distance right here is also x, because x is the radius. Okay. Use the calculator to determine the radius of the circle necessary to cause the area of the circle to equal the area of the rectangle. State the dimensions of the rectangle and the area of both figures. So the rectangle and the circle should have the same area because of this. All right, so we know that the area of the rectangle, we have found the area of the rectangle is related by this. And the area of the circle is related by this. And what do we know about the area of the circle and the area of the rectangle in respect to this problem? What do we know? The area of the rectangle and the area of the circle, what do we know? Area of the circle and area, yeah.
Is this problem going to be on the test?
Yes. It could be, I don't know. What do we know about the two areas? They are both areas, good. They're both in square something or other. What else do we know about the two areas? Number 2, use the calculator to determine the radius of the circle necessary to cause the area of the circle to equal the area of the rectangle. Thank you. So, area of the rectangle is this, yes? Area of the circle is this, yes?
Yes.
We want the two areas to be what? Equal. So x and this is equal to pi x squared, where x squared is the same thing as r squared. But we realize the height or the width of the rectangle, or the height of the rectangle, is equal to the radius. Okay? So we need to solve this. What do you think? Can we do it? So I'm going to bring this off to the side, because I want to go to a better board. You with me? Yay? All right, let's go here. Page. know that x I want these to be equal to each other. Okay? Pi is equal to what? 3.14. Yay? Distributed here and here. Still with me? If I want to solve for x in this problem, I need to bring everything over to the same side. So I'm going to subtract 3.14 x squared from both sides. Shh, almost done. It's our last problem. Yay or nay? Yay or nay?
Yay.
Do I need to use the quadratic formula on this problem?
No.
No. I have a greatest common factor between the two, which happens to be a letter. What's the letter? That's my GCF. X. So if I factor an x out, I get this. Yay or nay?
Yay.
So one of my solutions is x is equal to 0. Would it make sense? Would it make sense to have a radius of a circle and the width of a rectangle 0? No, so let's not use it. So let's solve the other one. So 8 minus 4.14x equals 0. Yay?
Yay.
Shh, don't clean up yet. I'm almost done.
You guys watching?
Yay or nay?
Yep.
What do I have to do with the negative 4.14 now?
Add it.
How do I get x alone? How are these being held together?
Add 4.1.
How are these being held together?
Equal sign.
How are these being held together here and here? Multiplication. What undoes multiplication? Division. Let's divide. Negative 8 divided by negative 4.14.
No say.
Negative 8 divided by negative 4.14. 1.93. So, if I have 1.93 as a radius, as well as the width, so as long as this is 1.93, which is our radius, that means our rectangle and our circle have the identical areas. Guys and girls, we have 6 minutes left. What are you all wrestling around for? We've got 6 minutes. Okay? Why was the 0? Wouldn't it make sense? Let me ask you this. What if our answer came out as one of our answers being negative? Why would that not have made sense? You can't have a negative length. Good. Good job, Andrew. Okay? So, there's tons of this that, we have area of a circle is 48 meters squared, blah, 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 a rectangle. So these are just typical word problems. We are going to continue working through these a little bit more on Monday. Okay? But I also, being that we will be working through these as a class on Monday, I want to make sure that you guys and girls have the review and know what it is. So Monday we'll deal with this. I will get through the rest of these problems, the word problems. And then our review page is page 11 or number. I think so. It is 12 here. So So that's your, I would like you to start on that. Now guys and girls, if you come with that blank going on to sit here and review, that's probably not the best way to go about going on this test. I would get a good start on those. I will have those worked out for you, and I'll hand out to you as a packet at the end of Monday, so you have that as a study guide. But we're going to go over the rest of the pages we have Monday, those word problems, because we're logically thinking, we're critically thinking. But I want to make sure you go through that worksheet number 12, which is pages 125, 126, 127. And I'll work all those out for you, and I'll have a packet come Monday for you, okay? Does anybody else need a picture of the worksheets?
I don't think you know.